already talked about what we're going to present in this presentation. First is we need to understand what is data science. Data science is a process that extracts knowledge and hidden patterns from huge amount of data. And the data can be structured, data can be unstructured, but it finds knowledge and insight from the data, and that knowledge can be used to sort out or to solve some intelligent program or intelligent task. Then we can say that process is data science. So what if we summarize that? It says that we can have a huge amount of data. From there, our objective is to extend the knowledge, and that knowledge has to be used to solve some kind of problem. If we do, then we can say we are doing the data science of task. Now the questions comes, already talked about, we need to extract the knowledge from there, and knowledge can be used to solve the problems. So to extract this knowledge, we need to use certain kind of methods, processes, and algorithms. And those processes and algorithms we need to know, only then we can extract the knowledge. Now the questions, if we want to know these methods, processes, and algorithms, then which are the subjects we need to know? We need to know machine learning, traditional statistics, domain expertise, and basic mathematics. So if we talk about the 4 pillars on which data science is standing, then we can say they are the machine learning, traditional statistics, domain expertise, and basic mathematics. If we know all those things, only then we can be good data scientists, or we can have good knowledge about how to solve the data science problem. Now, one question will come to your mind that why we are talking about, or what is the fundamental goal of data science? The fundamental goal of data science is to make quicker and reliable solution to the decisions. Quicker, try to understand. If we don't use the data science, simply, if we use a conventional technique, we can make it, but I try to understand it can take time, longer time, and the solution may not be reliable. But whenever we are using data science, then we can make the decisions quicker, and the decisions or the conclusions where we're going to make, it is reliable. For that one, actually, we are looking for the data science. Now the next question comes, so if we use a data science, then which kind of problems we can solve? We can solve a different kind of problems. Nowadays, there is no limit of data science. Approximately, we can use everywhere the data science. But here, just I have noted some of the applications where data science are prominently used. Here, see the medical diagnosis we have written here, recommendation system, optimization problem, fraud detection, speech recognition, face recognitions, sign language recognitions, natural language processing. In case of banking problem, then drug design, search engine, gaming, augmented reality, and many more where we can use data science. Fine. Next slide. Moving on. Now tell me, my slide is moving or not? Please report me. Hello, my slide.
It's not moving, sir.
Yeah, you could have told me this. Yeah, fine. So I have to like that, right? So here we talked about, right? Here.
Now it is moving. Yes. Okay.
So this is the definition of the data science already talked about, and these are the applications already talked about, right? These are the applications where we can use the data science. Fine. So now comes here, whenever we talk about the data science, then one term comes that's called machine learning. Then what is the relationship between data science and machine learning? We need to know. Already talked about data science teaches machine learning with other subjects, and these are the traditional statistics, domain expertise, and basic mathematics, right? So now if you analyze from here, then we can say machine learning is a step or is a component to data science. So now data science can be seen as a solution to some problems where the machine learning can be seen as a component of that process. So you try to understand the difference between data science and machine learning. Machine learning does a part of data science, but data science is talking about the whole process to solve a problem. That is data science. Now, if we talk about the different components of the data science nowadays, then machine learning becomes the main component of data science. Now, you can have a question, if you don't know machine learning, can you solve the data science problem or not? Yes, we can solve using, say, statistical methods, using, say, basic programming paradigm, we can solve, but you try to understand, it takes huge time, longer time. In machine learning, the programs are developed, or the algorithms are developed in such a way that once we give the data, then automatically it finds a kind of solutions, and its finding is very much quicker. So that if in data science, if we use some machine learning, then we can make a reliable and a quicker decision. That's why nowadays, whenever we talk about data science, then the machine learning comes in association. Fine. In next slide, already we talked about that machine learning is a main component of data science. Then we need to understand. We need to understand what is actually machine learning. But if you try to understand here, the definition is written. Then I'll explain it the example. Machine learning is programming computer to optimize a performance criterion using example data, past data. It says that we can have a huge past data or the example data. From this huge past data and example data, machine learning algorithm can be used so that the performance criteria can be improved. One of the performance criteria can be accuracy or it can be error. So if it is error, then objective would be to minimize the error. If the performance criteria is accuracy, then the objective would be to maximize the accuracy. Now the questions comes, how we can improve the accuracy using this statistical information, past data. Try to understand. Machine learning is talking about we can have like this kind of past data, and using this past data, we have to learn and we have to solve the problem. That's the objective. See here, one of the machine learning techniques I have given here, that's the neural network as a perception model. That I have taken two inputs here. You try to understand it's a kind of problem, say, for an example only, right? We have two inputs, one is BP, another one is heartbeat. And then we're finding the classifications here, whether somebody is suffering from diabetes or not. This is an example only for the illustration purpose. So this is yes, no kind of thing, right? So here we're putting the values for the first observations. We can put the values here. Then we can see the output. Now the questions, what can be the values of these W1, W2 kind of thing? These are the weights. Initially, these are called model parameters. So whenever we're talking about any machine learning algorithms, each and every machine learning algorithm must have some kind of model parameters. Our objective would be to optimize or to tune those model parameters. In case of neural network, the model parameters are or is weights only. So initially we can have a 0, 0 or any kind of weight, right? So simply we can give the data, then we can see what the system produces the output. Say the produced output is no, but here looking at the desired output is yes. So the network did some kind of mistake, and try to understand whenever some machine learning algorithm did some kind of mistake, only then some kind of learning is happened there. If there is no mistake, there is no learning in machine learning algorithm everywhere in case of all machine learning algorithms, right? So whenever some kind of mistake is there, then there will be certain kind of learning algorithm, right? Those things actually in machine learning are studied. So we can have a learning algorithm here. So based on this learning algorithm, we try to adjust the values of these weights because these are the model parameters. So in the second iteration, in the second observations, these weights are changed and these are given. Again, it looks whether it produces right its output or not. If right, then there is no learning. If there is a mistake, then there will be learning. In that way, actually, all the past input data are given here. Learning is done. And finally, when the problem is solved, or means whenever we get the optimal weights, W1, W2, so that the problem can be sorted out, then the learning is stopped. In that way, machine learning works actually. Fine. So in machine learning, the main objective is to train or to find the optimal value of the model parameters. Once we get the optimal parameters, using these optimal parameters, then we can find the best accuracy of the model. So now if we do the graphical representation of that, say we have a linear problem. This is a linear problem. We have white dots, 1, 2, 3. These are the white dots and these are the blue dots. Linear problem is one which can be solved by a single line, that is called linear problem. So we have here a linear problem, and here objective is to classify the white dot and the blue dot. That's the objective. But you try to understand, initially you don't know, because meanwhile you are looking and telling that if you make a line here, then the problem can be solved. But you try to understand, when it is given to the machine doesn't know anything. It knows only some kind of values. So initially we can give certain kind of weights here, and certain kind of line can be formed because it has the equation, that fundamental thing we are not going to talk about here. So based on that, it can make a line here initially based on the weights. So when the line becomes here, then we're looking at only three dots are classifying properly, and these are the misclassified. These are classified with the blue dots. If we have only this line, try to understand. So if you find the accuracy, then the accuracy becomes a 50%. Say, so we are not satisfied with 50% accuracy. Then again, it is learned. Now the line is changed here. How? By changing these weights actually, right? So these things we can understand only if we have, say, bigger session and mathematical session, everything mathematical, then only you can understand how it does. But I'm telling superficially, right? So values will be changed, then here the line will come. Now if we find the accuracy, we're looking at most of the dots, white dots, stay classified properly, and these blue dots all are classified properly. So now the accuracy can be, say, 80%. When it shifts here, now again say, with 80%, we are not satisfied. So again, we'll learn when the line comes here, then we can say, yes, now this line or this classifier is talking about a line, you try to understand. It makes a boundary only. So one side of the boundary is talking about one class, and another side of the boundary is talking about another class. So whenever we get this kind of line, then we can see the problem is solved. So when the problem is solved, now 100% accuracy can be achieved, then the learning process can be stopped, right? So here, if the performance criteria is accuracy, so whenever the line is established here, then we can get 100% accuracy. Try to understand. So our performance criteria is optimized now. But I try to understand this performance criteria is optimized based on these model parameters. So whenever we're talking about machine learning can have certain kind of algorithms from the past statistical informations. The learning algorithm try to tune the model parameters like the weights here in case of neural network, and based on these model parameters, finally it produces or it can solve the problem. In that way, actually, machine learning works. Fine. Now, next question can be, yeah, this is the one of the definition which is the most prominently accepted by, say, all over the world, and this is the most, you can say, modern definition of machine learning, which is given by Tom Mitchell, and this is the definition I'm not going to talk about, because if I talk about, I will waste my time. Then I'll give you the slide, no problem here. Then we're coming here. Next questions. Now, why machine learning? Everybody is talking about machine learning, right? You do that kind of thing. Somebody is working. So now the question is whether that problem cannot be solved using some conventional method. Yes. If the problem can be solved by the conventional method, then we don't need to use some machine learning. So for an example, if already we have certain kind of algorithms for the available, say, problems, then we don't need to use a machine learning. For an example, in case of sorting numbers, we have a number of sorting algorithms. That's why for sorting the numbers, we don't use a machine learning algorithms, right? But in some cases, we have a problem, but we don't have the algorithm to solve the problem. But fortunately, with the advent of efficient communications and technology, we are having huge amount of past historical information. And we know the problem we are going to solve, this kind of problem, but we don't have any ready algorithm for that. If the situation is like that, then machine learning algorithm is used. The learning algorithm is given there, the data is given, then automatically it learns and finds certain kind of solution from there. This is one of the situation. Another situation is that, again, using the past statistical information, if we use a conventional programming, and if we use certain type of a statistical tool, then step by step also we can find certain kind of solution. But you try to understand, if we do those kind of things using, say, statistical methods, using, say, conventional programming methods, then it will take huge time. So if we have a huge past statistical information and we want to have a quicker and a reliable decision, then we need to use machine learning algorithms to learn. Fine, but it's not about data science. You try to understand. Data science is talking about a process which can solve a problem, the whole problem. So we're coming to that, right? So here, just now I have added, because as all you are talking about application, just now I have added here one of the applications of data science using machine learning. See here, earlier days, whenever we apply for a loan to a bank, then the data of a person's or the applicant was analyzed by you can say an expert, or it was done manually. But I try to understand nowadays this manual convention has gone. Now those things are done by certain kind of intelligent software, by expert system, right? So you have to give all your interests. The expert system has already ready machine learning algorithms. Then it can decide whether loan will be given to you or not. So loan will be given if the algorithm feels that you are a good payer. Then only if the algorithm say classify you as a bad payer, then the loan won't be given because you are the bad payer, right? So in that way, it can be classified whether loan would be granted or loan would not be granted. Yes, no, in terms of that. But you try to understand some developed countries, like say UK, Italy, America, where if you apply for a loan, if the loan is rejected, then it's not sufficient. Then the bank has to explain why the loan is not granted. If these things come, then if we give only yes and no, then this is not satisfactory result. So in such a case, we have to analyze the data and we have to find the rule for which the loan will be granted and for which the loan won't be granted. So whenever somebody applied for a loan, means he has given his personal information, different kind of informations, means what is age, whether he is doing job or not, how much salary, this kind of thing is given. Based on that, it churn out, it analyze, and it finds certain kind of rules. If our objective is to show the reason, then we need to use different kind of machine learning tools. And these tools are called white box technique. We're coming to discuss about those things. These are called white box techniques. Using those white box techniques, we can churn out and we can find certain kind of rules. So if you apply and these rules are not satisfied, then you are rejected. If these rules are satisfied, then you are accepted. So here we have taken a data set from the UCI repository, and this data set is called German data set, and it had 1,000 examples and observations. And out of 1,700 was a good payer and 300 was a bad payer. And total number of attributes was 20. And we did certain kind of, we devised a model, we devised a data science model using machine learning, and finally we got this result, right? And this result says that if credit history equals to existing page, these are the values already available in a database. You try to understand whenever you want to make an applications of a data science, you must have past statistical information. So in the past statistical information, we had this kind of entry, and these were the values. So it says that the algorithm finds the rule finally after churning out, after analyzing the data. This is kind of rule. It says that if credit history equals the existing pay and credit amount less or equals to 12,204, then class good, means that he is a good payer. If this is true, then the person will be given loan. If it is not, then he is a bad payer, means the application will be rejected in that way, right? Now we have a question that yes, it will be working, that we found some kind of thing, some kind of rules. Based on that, some kind of decision can be taken. So now the expert system is ready. But you try to understand how this expert system is built. Now to build this expert system, we need to do a lot of things. Those things you have to know initially, only then you can apply. You can apply data science machine learning tool to find or to make some data science model to solve certain kind of problem. If you don't know all the parts and components, then your model will fail. Nobody will accept your model. So now we're coming to discuss about a data science model using some machine learning, which is not only for the research purpose, which is to solve some real life problem. So what kind of steps and what kind of things we need to do, we are coming to that one now. So I have here presenting here that this is a data science model. So whenever we want to make a data science model, the model which are working in the industry actually, all these phases are executed. So initially we can have a data set, right? I'm coming to discuss each and everything, data set. So after data set is available, then we have to prepare the data. That's called data preparations or data pre-processing. When the data is prepared or data pre-processing done, then we have to come for modeling and evaluation. In modeling and evaluation, we can have these kind of steps: model selection, model training, model evaluations. Now the first, we're coming here, the data preparations. You try to understand to make a model, more than 50% time is given for preparing the data, because if the data preparation is good, then your model will be good. That model will be accepted by everybody, by the organizations. So in data preparations, we can have these kind of steps, try to understand. These kinds of steps are there. Not in every problem, we need to use all those steps. Based on the data, based on the problem, we need to use these kind of steps. Now, it is our duty to understand in which process, which kind of data pre-processing step should be employed. So in data pre-processing, we're having this kind of thing: removal of corrupted data, number one. Then we're handling missing values. Then we have data visualization, data exploration. Then outlier detection, class imbalance problem, feature analysis, and finally data normalizations. Whenever this is done, then the model is given, then this data is given for modeling and evaluation. So now we're coming one by one. So initially, because now we're going to make data science model, data scientist, right? Your registers are explained very nice way in say very organized way what is actually data science. So coming there actually, so initially how about data set? Data scientist is a bit different than the machine learning scientist or also machine learning kind of thing. Data scientist is the one who is responsible for the whole organization, who is responsible for taking certain kind of decision, who is responsible for taking certain kind of administrative decision, who is called a data scientist, not only learning. So to become a data scientist, you need to know all the things. So machine learning, you need to know the domain. You have to be domain expertise, right? You have to domain expert. You need to know basic basic statistics, right? Those things you have to know. So whenever certain kind of problem is going to be defined as a data scientist, you have to identify which kind of problem you're going to solve. That is your responsibility. So problem identification in the data set, or the data scientist will do problem identifications. Now we have identified this kind of problem going to be solved. For example, so loan granted or loan not granted. This kind of problem is going to be solved, say. So this is the problem only. Now, second questions come: what kind of data would be required to solve this kind of problem? So data identification. These data identifications would be done only when the person is expert in the domain. Otherwise, he cannot identify the data which will be required to solve the problem. Right? After that, just we have identified these are the data, right? Then we have to do the feasibility study of the data, whether the data is available or not, whether we'll get the data or not. For an example, just we attempted certain kind of data, but in reality, we're looking that we are not able to collect this kind of data, then the whole project will say collapse. So we have to study of the data, whether data will be available or not. So once it is done, then we have to start data acquisitions. Means we have to start collecting the data here. So this is about the data set. Once this data set is done, then we have to come for the data preparations. In the data preparations, we're coming here. Already talked about that the first step is what you see here in the data preparation. The first step is removal of corrupted data. So coming here, this is the removal of corrupted data. Now the questions: what is the need that removal of the corrupted data? What is the need of that? Initially, you try to understand what is actually corrupted data. Say here, we have a problem. See this table, try to understand this table, right? So we have a certain kind of attributes. We have age, we have weight, we have height, we have pressure, we have heartbeat, and there is certain kind of classification. So we are looking at the data. Here looking that the heartbeat written say 300, heartbeat 400 is a corrupted data. Why? Because these data are erroneous data, because these data not in format, these data not in range, because heartbeat cannot be 300, 400. So these kind of informations whenever we'll have, these are a kind of corrupted data. Fine. So this is one of the corrupted data. Similarly, we can have a different kind of corrupted data if the data is not in format. So you will see numerical format, but the data is available in say it's a categorical format. Say you need to have a continuous, but it is available in a categorical format. So it is corrupted then. And so there can be certain kind of outliers, but we have different section for the outliers. We're going to talk about outliers there. Then we have a missing values. This also belongs to corrupted data, but we have a separate section for missing value here. So in this case, you try to understand if we have this kind of corrupted data, then what is the problem? So corrupted data is there in the data set. Then what is the problem? The problem is that if we train with the corrupted data, then the training won't be good. Then the model what we're going to devise won't be optimized. It won't be acceptable. So if we do the removal of corrupted data, then what does it do? It improves the quality of the training and reliability. It improves the quality of the training and reliability. So if the training of a model is good, it means what? The model will be accepted by the organizations to solve the problem. Fine. So you try to understand if we have a corrupted data, then we need to remove those kind of corrupted data. Next question, which kind of data can be corrupted? If you are very much interested in data science, you need to study on that, right? So we can have A, B, C, D. Already I have shown you one kind of corrupted data. I'm going to show all the corrupted data, but if you try to understand, if you're interested, you want to explore more, then you can see on the Google here. So here are different kind of books you can follow. So here we have A, B, C, D, E, and looking at D is the corrupted data. Then what we can do? We can remove this one, then we can keep A, B, C, D only in the data set, and then we can do further processing. Coming to the next one. After corrupted data, the database can have some missing values, right? What is actually the missing values? So we have a data set. For example, this is a database. This is a very small database, right? So looking at here, we don't have the data. We don't have the data. We don't have the data. But you try to understand, if you talk about the data science, data is must. If data is not there, we cannot generalize. Model cannot be generalized in, say, good way. So whenever we have certain kind of missing data, that is not good. So we need to do the treatment of the missing values. Somehow these values has to be improved, or somehow this value has to be imputed, or some kind of treatment has to be given here. So if we do, or if we handle the missing values, then it improves quality of the training. Fine. So I already talked about the training is good, then the model is good. So how to handle if this kind of values are there, this kind of missing values we have in our database, then how we can do? What we can do? Yes, we can handle it in two categories, and these are called, one category is called, or one type is called deletion, another one is called data imputation. So coming to that one, what is deletion? Simply in deletion we have three kind of things here by which we can delete the data, or we can handle the missing values. So here, deleting rows, deleting columns, or deleting the pairwise deletion. So coming to the first one, deleting rows. So we are looking at in this database, right? In this database, we are looking at this data is missing here. So it's better to remove the whole examples from the training. So we remove this one and simply just we refine the database, and this will be a new database. So if you do the handling of the missing values like that, then it's called deleting rows. But here I'm just pointing out one point. Whenever we do such kind of thing, then automatically the size of the database is going to be reduced. And you try to understand machine learning model or the data science model is built over the data. So if the data size is reduced, then automatically the generalization capability of the model is going to be reduced. So if you're having number of such kind of missing values data, and if you say omitted from your database, the size of the database is going to be reduced. So be careful on that. So apart from that, we are having another kind of deletions, and here is talking about deleting the rows. And look, we are looking at here in this case, right? Here we have a missing values. Here we have a missing values. Here we have a missing value. So in number of places we are looking at missing values are there. So now if we want to delete the rows, so how many rows we are going to delete? 1, 2, 3. So if we delete the 3, then automatically this database size is going to be reduced. So it's wiser what? So instead of these observations or the rows, we are going to delete the whole columns from here. So if we delete this one, then finally the refined database becomes like this. And now this data set can be taken for further analysis. And now if we do, so this is done. And if we do the pairwise, it says that pairwise means say we have 1, 2, 3, and 3 independent parameters and 1 dependent parameter. Now say we are interested in doing the analysis of with 2 dependent parameters and 2 independent parameters and 1 dependent parameters, and they are BP and heartbeat. We are not going to consider the weight. As we are not going to consider the weight, that's why we are not going to treat this one. You try to understand. In case of pairwise, we need to understand which kind of attributes we need for the analysis, and we will be concentrating only for those kind of attributes. So here our objective is to deal with only BP and heartbeat. So we have taken BP and heartbeat, and from here we have seen here we don't have the data, so we omitted this one. Here we don't have the omitted this one. Here we don't have omitted this one. But you try to understand, here we don't have, but we didn't do any kind of treatment here because now we are not going to do certain kind of analysis with this column. So if we do in that way, so that is called pairwise actually, deletion. So deletion is one way. The other way is the data imputation. Data imputation means the creating the data artificially. That is called data imputation. So here actually initially we didn't have any kind of data. So missing value is here. So now we're not going to delete state. We are going to do data imputations. means we are going to create the data here. So now the question is how this data can be created. Data can be imputed in different techniques. These are the techniques. We can use a mean here, we can use median, we can mode, we can linear interpolations, linear regressions, KNN, and different kind of machine learning algorithms. And many people are working and doing their PhD in data imputations because you can propose some kind of new algorithms for data imputations, right? So if we talk about some standard tool by which the data imputation is done, so these are the standard tools. So based on the problem, based on the data, you have to use one of the standard tools, right? If you do simply the data imputations, or if you are doing the research, then you have to devise due kind of algorithm for the data imputation here. So for example, we're going to impute the data using some mean here. So how we can going to find the value of this one? We are going to find the mean of this column, except this value. So we have written here, this is 70, 70, 65, 65, 59, 55, like that. We have taken all the values here and we found here the mean value, and the mean becomes 67. Now this 67 becomes the imputed value for this missing value. So in that way actually imputation can be done. But again, one thing can be pointed out here, there imputation is not again suggested, because whenever you are going to do imputation, it means what? You are going to create some artificial data. This is not the actual data. Fine. So again, we have a cap here also. So using also mode, if it is a categorical data, then instead say mean, we can use a KNN or we can use a mode like that, right? So for an example, we are going to here say KNN for impute the data, and here the value of K is taken for. You try to understand KNN as a machine learning algorithm, and where the value of K is the tunable parameter, means you have to consider how much value you are going to take. So now say we have taken here the value of K, that is 4. So if you take the value of K equals to 4, then this. Out of this one, which one is the majority? This is yes, this is no. This is yes, this is no. Which one is the majority? Yes is the majority. That's why the value of this missing data would be imputed by Y, right? If it is categorical. So in that way, actually, based on the data, based on the nature of the data and the techniques which are available, as a domain expert, you have to decide which kind of technique you are going to adopt, right? So in that way, we can handle the missing values. After handling the missing values, we have a next part or next step that is called data visualization and data exploration. What is that actually? Means here in this case, the data has to be explored. A different kind of say statistical tool can be used here. Different kind of characteristics, underlying behavior of the data can be analyzed by some numerical computations or also by the visual tool. So what does it do actually? If we do data visualization and data exploration, then how does it help us? It helps, I have written here, it helps to understand underlying behavior of the data, which helps to take right step in data preparations and modeling. Because in data preparation, we need to take different kinds of decisions, right? As we are looking from the outer view or the black box view of a model, that's we're thinking that things are simple, but you try to understand when you want to do mathematically, right? If you want to understand mathematically, things are not so simple. Different kind of situation will come. So in this situation, which kind of methods will be used? So that one can be solved if we know the characteristics of data. So if we do the data visualization and exploration, whenever certain kind of situation will come, that situation can be sorted out very easily based on the characteristics of the data. Now coming how we do data exploration and visualization. The data explorations can be done. There can be number of techniques, number of measures, right? Just we have taken here the 3 measures, and these are the statistical measures. Written here, this is the mean, this is the median, and this is the variance. Using the mean and median, what we can find? We can find the central tendency of the data. And by variance, we can understand the spread of the data and how it spreads. Clear? Now coming here, say we have observation. Try to understand right mathematically, right? We have an observation here. Means we have a list or we have an attribute here. And the attribute having this kind of values: 21, 89, 37, 34, 67, 97. So if we find the mean of this one, then mean becomes 61.4. And if we find the median, it becomes 67 actually, right? Now, if there is no big deviation, we are looking at there is no big deviation, right? It's a small deviation kind of thing, right? So if this is not, if there is no big deviation between mean and median, then we can say data are uniformly distributed. Data are uniformly distributed because there is no big deviation between mean and median. Fine. Now, if there is a big difference between mean and median, which means what? The data are very much, you can say there is no uniform distribution. That's why whenever somebody talks about the salary package of a college or company kind of thing, then the mean doesn't work, only you try to understand, right? So you have to find also median. So then you have to find whether there is a big difference or not. If there is less difference, then you can say, oh, okay, the uniformly distributed means everybody is getting certain kind of thing. Means some kind of thing is there. So we can understand the nature of the data by mean and median. So they're coming here, one more instance is here. So we have a state of sorted list here, right? So here the values are 21. We have here 20, 23, 24, 25, 84, 76, 50, like that, right? So this is our observation now. Now if we find the mean becomes 46.1. And so median, how much? 25. So if there is a big deviation between mean and median, already we talked about the data are not uniformly distributed. It is not uniformly distributed, and there can be a certainty that data are concentrated either in the lower range or in the upper range. Data are concentrated in the lower range or the upper range because there is a big deviation between mean and median. So see here, in this case, the data are very much concentrated to the lower region. So lower is a 20, and here we have a much data which are very much concentrated to 20. So if this kind of thing is there, then we can have a big difference between mean and median. So if so, then we can understand, yeah, data concentration is either mean, either lower or either in upper. Means data are not uniformly distributed. Now we have another instance here, right? So you try to understand, if we know all those things, then we can understand the behavior of the data set. By understanding the behavior of the data set, number of decision problems during the design of the model we can take. Because arbitrarily, whenever somebody works for the data science, people jump directly, I will work with decision tree, but I don't know the background, I don't know the characteristics of my data set. Directly I jump, I will work with neural network. But if try to understand, whenever we have the problem, we need to analyze it, and which one fits best, that one we need to choose for particular problem, to solve particular problem, right? So that's why this exploration and data visualization is required. Now see here, we have this kind of thing, right? One of the items whose value is 200, and all of the item 21, 89, 34, 67 kind of thing, right? So here we are finding mean. Mean is 82.2, and if you find a median, it becomes 67. So there is a big deviation between mean and median. So whenever there is a big deviation between mean and median, there is a chance that there can be outlier. So if you see carefully the whole set of observations, so that this observation, the item 1 is having how much? 21, 89, 37, 67, and suddenly here 200. So 200 means what? It can be outlier. You try to understand, because this value is not associated, it's not very close to the mass of the items. So we have an outlier here. So you try to understand, whenever we can have a big deviation between mean and median, so there is a chance that the data set can have some outlier. So whenever we can understand that data set is having an outlier, then before processing the model using any machine learning classifier, so outlier detection has to be done. Because if there is outlier, if the training is done, the training won't be good. Try to understand. That's why actually you do data exploration kind of thing here. So simply here I have one more. So if I talk all those things, then I cannot finish up. So here again we have a number of things. In that way, data exploration kind of thing is done. After data explorations, we are coming to data visualization. What is that actually? Data visualization. Data visualization helps in understanding the distribution of a numeric data in series of intervals. So if we do, then what is the benefit? The benefit of that is that it gives us quick understanding of the data. For an example, we have this kind of values here, right, in the database for certain, you can say, feature. So here we can have 20 kind of things, right? But you try to understand in say when we solve certain kind of problem, we can have 1,000 and 1,000 observations. So if you want to make certain kind of quick observations, so by looking at the data, we cannot understand. So for that one, we need to have a histogram or some kind of visualization tool. So one of the visualization tool is the histogram. So here, what I have done a program here where just it finds how many items are there in between 30 to 40. How many are there 40 to 50? How many 50 to 60? How many 60 to 70? How many 70 to 80? Kind of thing, right? We have made a pictorial representation here. So simply if you see here, then we can conclude, yeah, we didn't say 30 to 41. We didn't say 40 to 54 kind of thing. So we can have a quick understanding of the data if we make or if we use certain kind of visual data visualization tool. This is one. Another thing is that here, try to understand, right? I have taken two data sets from the UCI repository, and I made say a histogram for the class levels, means how many observations belong to which class. So I have taken this is the iris problem. In the iris problem, there are three classes: iris setosa, iris versicolor, iris virginica. So I found that how many observations belong to this iris. I mean, how many classes are there in this class? How many observations are in this class? How many observations are in this class? I have looked at, so in all of the cases is around 50-50 kind of thing, or 50-50, right? So if we have a 50-50-50, then this kind of database is called balanced database. Means all kind of classes are equally distributed there, fine? And now I have taken on thyroid. This is thyroid dataset. So in thyroid, two classes are there, 0 and 1. So in this class, 0 class probably, or one class is around more than 350, and another class is more than 50 only. This is one class is having this number of observations, and another class is having this number of observations. So from here, we can understand that the data set is not balanced. If the data set is not balanced, now if this data set is given for the training purpose, then the training of the algorithm won't be generalized and won't be reliable, because the model is going to be biased to the majority class. So whenever we can analyze and we can see this kind of situation is there, then we need to give certain kind of treatment for the imbalanced data set. So by data visualization, we can understand the behavior. Based on the behavior, we can use or we can give certain kind of treatment. Here we have another kind of visualization tool that is called box plot. What does it do? This is an effective, you see it here, just I'm reading it out, an effective mechanism to get a one-shot view and understand the nature of the data. So if you make a box plot, then we can understand the nature of the data. One-dimensional data, you try, there can be number of dimensions, but it talks about the only one dimension at a time. So see here, in case of box plot, I had a 4-dimensional data because it was a iris data set. That's why this was a kind of say snapshot of the box plot analysis. After that, I have done it for one attribute only, this attribute only. Just I have done the analysis, and this kind of box plot has come up. So what it talks about, what it says, in box plot we can have the statistical summary. This summary in 5 parameters, and these parameters are minimum, first quartile, median, third quartile, and maximum. This one is called minimum. This one first quartile. This is median, third quartile, and maximum. And whenever we do a box plot analysis, if some items are beyond the minimum or beyond the maximum, then we can say they are the outliers. So if you analyze the iris data set with the second attribute, then you can see that there are 4 means samples of the patterns which are treated as outliers. As we have seen, as after doing the box plot analysis, we found that there are 4 outliers. So before executing or before training the model with iris dataset, our endeavor would be to sort out or to remove these kind of outliers. So if you remove this kind of outliers, then the training will be good. After that it comes, that is called data visualization, and we have done it here using say scatter plot. So it talks about till now whatever we have done, this is done for one attribute or one dimensional analysis. Means we can take one dimension and then we can analyze on it. But I try to understand whenever it comes to which one is scatter plot, it does the analysis of 2 dimensions. It finds the relationship between 2 variables. So we can have a variables here, we can have another variables here. So now we can plot here, that we can see that whether their relationship is linear or non-linear. So from here we can see it's a linear, it has a kind of linear relationship. So if it is depicted that there is a kind of linear relationship, so if it becomes a problem, then this problem can be sorted out using some linear machine learning tool. Because there are some linear machine learning tool, there are some non-linear machine learning tool. So if the scatter plot, or if the distribution is not linear, but the relationship is not linear, we can understand by the graph, right? You have to understand all those terms if you want to do data science, if you want to know machine learning. You need to understand all those things mathematically. So if you find that the relationship is not linear, there's a kind of non-linear, then you have to use a non-linear tool here. Fine. So after data visualization and data exploration, you try to understand this part is not over yet. Many things are there. The data visualization, data exploration is a separate topic and a subject also. Fine, because you have to understand the nature of the data. Only then you can apply different kind of tools to solve the problem. Otherwise, not. So after this one, after data visualization, data explorations, we're coming here. That is called outlier detection. Fine. So first of all, we need to understand what is outliers. Outliers far from the rest of the observations or center of the mass of the observations. Means if we have certain kind of observations which are very far from the center of the mass, or most of the observation of the space, or the problem space, then we can say those observations are outliers. So here you can see one example. So these are the patterns or observations. All those patterns are very much close and they are looking very much normal. But if we talk about this data, say this data is very far from this, and also from the center of the mass. Similarly for this, similarly for this. So if we have this kind of data, then those data are treated as the outliers. Now the questions, if outliers are there in our database, then what is the problem? The problem is that it can result, means the outliers can result in a poor fit and lower predictive modeling performance. Means the model what we are going to devise, the performance won't be up to the mark, because in your data sets you are having outliers. Clear? So now if outliers are detected and removed, then what kind of benefit we can get? We can feed the data properly and enhance the performance of the model. So the model performance will be enhanced if the outlier detection is done properly. Clear? And now again one line. Histogram or scatter plots can be used for 1 or 2 dimensional data. Then we can do this outlier detection using histogram and scatter plot, but you try to understand these are only applicable if we have 1-dimensional or 2-dimensional data. But you try to understand nowadays we have a multi-dimensional data set or high-dimensional data set. So whenever we have a high-dimensional data set, then this kind of simple statistical method cannot identify the outliers. Then we need to use some advanced statistical tool or the machine learning algorithm to find the outliers. Once they are found, then they can be removed from the data set. So coming here to talk about some of the outlier detection technique. The first one is called isolation forest. It's a tree-based outlier detection technique. And it is believed that whenever we have the data, all normal data are having the similar kind of attribute values. So whenever we have certain kind of data or the observation in the database whose attribute values are totally different than others, then they are the outliers. This working principle is applied here and finds the depth of the tree, and based on the depth of the tree, actually the outliers are detected using isolation forest. Fine. It's a very common and very effective, that is called isolation forest. Again, I'm telling one thing, those who didn't do, they're looking at in isolation forest, if you see the mathematical part is really very huge. Many things are there, but you try to understand, if you want to implement in Python, just you need to use only the isolation forest, one module, nothing more than that. Simply use isolation forest, then it will work. You can find the dataset, and then dataset can be used for the machine learning classifier. Simply it can be done. Those who didn't do, or those who didn't have the experience in Python, then they cannot understand. But things are very simple. But if you want to do mathematically understand, and basically if somebody wants to do code using say basic Python or using say basic C programming, then they need to know all the mathematics. Then only they can do. But there are a number of packages in say Python, right? By that we can solve this kind of problem simply. After that, we have this minimum covariance determinant, then local outlier factors. This is one of the prominent techniques, local outlier factor. And after that, we have one class SVM. All are having certain kind of detail, but I'm not going to detail. I have detail and mathematical detail, all the things with me. But here to summarize within 1 hour, just I have written some of the things, but still I'm looking that it's not possible to talk about. But just you know that these are the techniques by which we can do, which one we can find the outliers from the data set. Okay, so after that, here now some questions comes now yeah, after that we have class imbalance problem. Class imbalance problem, what is that? See here, we have a problem, and it's a linear problem. Already talked about if a problem can be solved you by a line, then this problem is called a linear problem. So we have here a linear problem. Fine. So here we have a black dots. This is one class, and we have another class that is blue dot. They are the another class. Try to understand, right? So if you count here, how many blue dots are here? 1, 2, 3, 4, 5, 6, 7, 10. If you count here, how many? 20. So now the ratio is 1:2. So number of blue dot is less, number of black dot is more. So now if this database is given to any one of the machine learning algorithms, so when the training would be done, then the classifier would be biased towards the black dot, then the blue dot. Why? The thing is that already talked about the algorithm is in the first 2-3 slides, we have seen that the algorithm is trained or the classifier is made based on the data. So whenever the data is misclassified, some kind of learning is done there. Fine. So if we have a 20 black and 10 blue, so it is expected that the number of black dots which would be misclassified by the classifier during the initial phase would be more than the blue dot. So the learning chances of the learning of the classifier would be more for the black dot. More times it would be learned. Whenever one black dot is misclassified, some kind of learning would be there. And whenever some blue dot is misclassified, then some kind of learning would be there. So misclassification of blue dot would be lesser than the black dot because number of black dot is more during training. So when the model is trained, this model will have a higher impact of this black dot. Try to understand, right? So once this kind of model is devised, and now this model has to be applied to the new data. So whenever some new data will come, then this classifier will try to classify this new data to the black dot because the classifier, what we have made here, is a bit biased, and that is biased towards the black dot. So if we have this kind of database, you try to, whenever we have this kind of database, if the training is done, that training is a biased training. So if we have a biasness in the database, then it doesn't work well. So what we need to do, what we can do, you try to understand whenever we have which one class imbalance problem that it biases towards the majority class. If it biases towards the majority class, then finally the performance of the classifier will drop. So fortunately, now the question how we can handle. Yes, we can handle. Fortunately, we're having number of machine learning algorithms by which we can sort out this kind of problem, this class imbalance problem. So here we have especially those who are much popular. There are 3 approaches to handle the class imbalance problem. One is called sampling, then say algorithmic, then say ensembling. These are the approaches. Now this sampling approach, what actually we do in sampling approach? In sampling approach, either we increase the number of instances or we decrease the number of instances. Fine, that is done in say sampling method. Based on that, the sampling method is categorized into 2 methods, 2 approaches. One is called undersampling and another one is called oversampling. What is actually undersampling? Undersampling reduces majority class instances, right? So that some kind of balancedness can be restored in the database. If we talk about here, so here we have a 20, here 10. So what we can do? We can remove the 10 black dots from here so that we can keep here only 10 black dot and 10 blue dots. So if we have a 10, 10, then we can say now the database is balanced. Clear? So if we do like that, then that is called undersampling. Means we are reducing the majority class instances. So how we can do? There are a number of undersampling techniques, and the people who are working there, those who are the data scientists, they are very much keen in this area. So number of algorithms are there. Random undersampling, atomic link based undersampling, condensed nearest neighbor undersampling, and the near means number of undersampling methods are there. These are very old, right? These are very old. There are a number of new algorithms are there, and people are working there also, those who are working in data science. So apart from this undersampling, we have another one that is called oversampling. What does it do actually? It increases the minority class instances. If we talk about with respect to this problem, then we can say we have a 10 here, 20 here. So what we can do? We can increase here more 10. So here 20. If we increase here more 10, that is become 20. So 20, 20. So now the balance list is now the balance of the data set is restored. That approach is called oversampling. Similarly, there are a number of techniques by which we can do oversampling. These are the ROS, SMOD, borderline SMOD, severable SMOD, Erasine. There are a number of new techniques are there. So those who are intended to do or to pursue the research, they can work here, right? Undersampling, oversampling, right? If you are interested, you can talk to me also, no problem. I'm very much open. I'm very much dedicated for the research, right? If somebody is interested. Apart from this sampling, then we have an algorithmic approach. What it does actually, it does what, I'm not going to take you much time. I know that I crossed my limit. So here what does actually, just I'm telling this one, it does what? It actually changes the cost function, because whenever a learning thing is done, whenever a pattern is misclassified, then there is a kind of, say, learning. So during learning, so misclassification cost is given. So higher misclassification cost is given for the minority class, because this minority class gets less chance in you can see in the learning. That's why whenever some minority class is, say, misclassified or some mistake is done here, then during training, the impact of that would be given more. Means the weight during the misclassification, during the learning would be given more for the minority class, so that some kind of balances can be drawn up here. That kind of approach is called algorithmic approach. And then there is some ensembling approach which merges this undersampling, oversampling with the algorithmic approaches and produces very good promising results. And people are working right now in say ensembling approach to sort out class imbalance problem. Not going to discuss, just showing you. After that, we need to do feature selection, or that is called feature engineering. We need to do feature engineering, right? Because number of things are there in the feature engineering. You need to do in detail. One topic is there for feature engineering. And then after feature engineering, data normalization we need to do. But I try to understand, always data normalization is not required. Always not required. For all techniques, it is also not required, right? Analysis there, right? After normalization, we need to do some model selection. Directly we jump, and in model selections, I have classified all those things, what kind of algorithms are there. Supervised means based on the learning paradigms, the machine learning algorithms are classified into supervised, unsupervised, reinforcement. These are the classification. These are the tasks, and these are the algorithms for the supervised learning, and these are the algorithm for unsupervised. How the training is done in the supervised learning. This slide is included here. Then these are the algorithm for unsupervised learning, and here these are the algorithm for reinforcement learning. And after that, we have here how the model can be selected, because there are a number of algorithms for the classification. For a particular problem, which kind of method or which kind of algorithm should be chosen, here we have the discussion for that. Actually, not going to discuss, don't have time. Then we have a model training. So generally people what do, they generally take 80% for training, 20% for testing. And this method is called holdout method, but this method is having certain kind of problem. To sort out this problem, the k-fold cross validation is there. In the k-fold cross validation, this is the working principle. The whole working principle is described here. Again, in k-fold cross validations, we're having certain kind of problem. If the data set is very small, then k-fold cross validation cannot be done. To overcome that problem, actually, the bootstrapping came in existence. This is another kind of paradigm, right? And after that, what would do? with model evaluations. If it's a classification problem, then you need to make a confusion matrix. With example, I have explained nicely here, but due to paucity time, we cannot do. So for the classification, we need to find, say, accuracy, right? For which one? For, say, regression problem, we need to find R squared. For say clustering problem, we need to find different kind of performance measure, and they are called internal evaluation. One is, and then the coefficient is called relative coefficient or the relative width, and second one is called purity, like that actually. Thank you everybody. Up to here I wanted to discuss. Fine. Thereafter in my slide I have different kind of learning algorithms in detail mathematically, right? So in detail mathematically, if I discuss one of the algorithm, then it takes the whole time. That's why I didn't incorporate, but I wanted to give you one view. If you want to make a data science model, then which kind of steps you need to do, so that you can claim that really I have designed or have made one data science model which can sort out some problem in reality. Thank you everybody. Thank you.